Hi, I am Jyotsna Manchiraju, presenting my master's thesis project on prediction of children's age range based on book synopsis. As the title suggests, this research is a prediction task, and the material that is needed for this research is text data pertaining to books. Books have guided our society in many ways and have proven to be a helpful tool in the art of teaching, learning, and nurturing children. Traditionally, books were available only in bookstores and libraries. But with the advent of internet, books are available in e-commerce websites, in e-libraries, as e-books, etc. Features of books. When a book is made available online, the bookseller enters a few standard details regarding the book, such as book title, author name, book synopsis, price, and so on. In some cases, the suggested age group may also be included as part of these details. Typically, it serves as a guide for readers and those wishing to purchase the book. The research of this thesis is about predicting the suggested age range for a book based on its synopsis. What does book synopsis mean? Book synopsis can be defined as an overview of a given book. Book synopsis provides a simple summary of the plot, story, and characters of a book, giving a little curiosity to the reader. In the picture here, we can see the example of a synopsis written for Harry Potter and the Sorcerer's Stone. What does age range of a book mean? Recommended age range of a book is a category into which books can be classified. 3 age ranges are considered in this research. They are 0 to 5 years, 6 to 10 years, and 11 to 18 years. In this thesis, a machine learning based data driven approach is proposed for predicting the recommended age range from the text synopsis of a book. Various combinations of text features and machine learning models are investigated to determine the best performance for the age range prediction task. The figure here explains the processing pipeline for age range prediction task. One can see the book synopsis taken as input, features extracted and processed through machine learning model, and the corresponding age range generated as the output. Research questions. In this work, the following research questions are considered. What are the best text synopsis features which provide the best performance for predicting age range? What are the best machine learning classifier models which provide the best performance for predicting the age range? What combination of features and models provide the best performance? Research papers related to text-based attribute prediction are considered. 3 categories of research papers are studied for this research. They are topic classification, sentiment analysis, and author attribute prediction. Here are the details of text classification and sentiment analysis papers in brief. Papers related to author's attribute prediction are listed here. These papers have worked over predicting author's age and gender considering small texts like blog posts, Twitter handles, social media posts, comments, etc. Most of the papers have used English texts, while some of them have used Dutch, Roman, and Urdu texts. Age recommendation for text is a research work done using French texts. French texts such as newspaper clips, books, and magazines are used to suggest the reader's age for a given text. This paper is the closest one for our research. However, its focus is upon French language texts and not English language. To the best of knowledge, the problem of predicting recommended age range for English books has not been covered in existing literature. The major steps involved in solving the problem are data collection, data pre-processing, feature extraction, data classification, comparison of results, and lastly, determining the best combination of features and model. Let us look into each step in detail in the upcoming slides. The data for the problem was sourced from two publicly available resources on the popular data science portal kaggle.com. The resources, namely highly rated children's books and stories and 1000 children books on Amazon, are chosen. The first resource is provided as two tabular structures in comma separated value, that is .csv format. The files are named children underscore stories.csv and children underscore books.csv. The second source is provided with one CSV file named as books underscore data.csv. We can observe that each file consists of book title, book description, and the reading age columns. Here is the first stage of data preparation methodology. Firstly, we have to download the CSV files from kaggle.com. Clean the data in the files with respect to reading age column. Since each file has a different column name for reading age, rename the column names and combine the data to form a new file with clean records. Clean the text data from description column. The description column represents the book synopsis. Extract handcrafted features from the cleaned text data for book description. Extract statistical features such as word-to-vec, doc-to-vec, and BERT. Partition the data with respect to reading age column. The row indices of original data are noted in the training, validation, and testing sets. The training, validation, and testing indices along with features are utilized as part of machine learning model training and evaluation methodology. In the second stage of data preparation methodology, the data is split into three subsets of training, validation, and testing splits, where 65% of the data is segregated into training set, 20% into validation set, and 15% into testing set. The table on the screen gives the count of records per set with respect to age range classes. Feature extraction techniques such as word-to-vec, doc-to-vec, BERT, and handcrafted features are used. Word-to-vec refers to vector representation of words. The vector representation of words is achieved by continuous bag of words and skip-gram techniques. Doc-to-vec works similar to word-to-vec. Doc-to-vec refers to vector representation of documents or paragraphs. Another technique used is BERT. BERT stands for bidirectional encoder representations from transformers. BERT is helpful in understanding meaning of words or sentences. Handcrafted features are also used in this research. List of handcrafted features can be found in the table here. Let us look into machine learning models that are used for this research. Firstly, KNN. KNN stands for K nearest neighbor, where K is a given parameter. K nearest neighbors algorithm performs classification by examining the distance of the test sample to all the training samples. The training samples are first sorted in the order of increasing distances. The majority label from among the labels of K nearest training sample is considered the predicted label for the test sample. Next is SVM. SVM stands for support vector machine. For a two-class classification problem, the linear hyperplane which separates samples of two classes can be considered as the classifier. The kernel parameters of radial basis function RBF, polynomial, and sigmoid are used. The next model that is used is extreme gradient boosting, XGBoost. This is influenced by gradient boosting framework and is used to solve classification problems. Gradient boosting decision trees build a model of multiple decision trees which are assembled to obtain accurate results. The next model is light gradient boosting machine, LGBM. LGBM works on gradient boosting framework which is based on decision tree algorithms. LGBM adopts the method of leaf-wise tree growth. LGBM is based on the concepts of gradient-based one-side sampling and exclusive feature building. The last model is multi-layer perceptron. Multi-layer perceptron is a class of artificial neural network. The basic building block of MLP is known as a neuron. The input features are presented at the first layer of the MLP. The transformed features are multiplied by the weights between the layers. The output from the last layer is considered as the model prediction. The performance of a machine learning model is measured in terms of its accuracy in predicting the outcome of the given data. The terms such as true negative, true positive, false negative and false positive can be understood from the table here, which defines the confusion matrix for a two-class setting. For a given classifier, the hyperparameters are varied to determine the best setting. Here we use performance on a validation set as the criterion. As the performance measure, the F1 score is used. F1 score is defined as harmonic mean of precision and recall, where precision is the ratio of true positive predictions to the total number of positive predictions, and recall can be defined as the ratio of true positive predictions to the total number of positive samples. As the picture suggests, the training and evaluation protocol has two stages. In the first stage, for each feature, a classification model is chosen. A set of associated model hyperparameters is initialized. The model is trained for each setting of hyperparameters. The hyperparameter setting, which provides the best performance F1 score on the validation set, is recorded. In the second stage, the training and validation sets are merged into single and final training set. The model is retrained on the merged training set using the best hyperparameters determined previously. Finally, the trained model is evaluated on the test set. The resulting score is considered as the final performance score for the combination of the feature and the classification model. 5 machine learning models of KNN, SVM, XGBoost, LGBM and MLP classifiers are used as an experiment to train and validate the text data. Feature extraction techniques such as word-to-vec, doc-to-vec, BERT and handcrafted features are used. As the results show, word-to-vec features provide the best performance for model-wise setting and the ensemble stack setting. The result shows that capturing the context of synopsis text at the word level is important. Although BERT is considered a successor to word-to-vec, its performance is relatively inferior across the models. This could be due to the much higher dimensionality of BERT causing overfitting in the models. Also, it is possible that models such as BERT are more suitable when the dataset size is very large. Doc-to-vec features are likely more suitable for large documents and not for the paragraph level synopsis present in the current dataset. Finally, handcrafted features lead to worse performance. This is likely due to the lack of correlation within the representations of each class. Further, the classification models of KNN, SVM, XGBoost, LGBM, and MLP are stacked to form an ensemble model. Combined dataset of training and validation features is given as input for this model. Ensemble model combines the output of each model and runs through a meta-learner to improve model predictions. The table here portrays F1 scores obtained for ensemble model over individual features. The best score is obtained for word-to-vec feature. From the results, it can also be observed that SVM is the best performing classifier, outperforming other popular models such as LGBM and XGBoost. This result is likely due to the relatively small size of the dataset and due to the tendency of more powerful models to overfit in such a setting. The flexibility of MLP architecture is likely the reason it comes a close second in terms of performance. The best performing classifier in SVM with parameter C set to 1 and RBF kernel whose gamma parameter is set to 10. The features used are word-to-vec. For this best performing model, the confusion matrix with respect to the test set can be seen in this table. The relatively smaller number of samples for ages 11 to 18 impacts performance for that group. However, performance is quite good for other age groups. My sincere thanks to members of UpGrad and faculty of LGMU for providing me with this opportunity. Thank you, sir.